Welcome to Factory Automation Future, where we witness the incredible technological transformation of discarded banana stems into valuable, sustainable industrial resources. Banana plants are cultivated globally in massive quantities, providing essential nutrition to billions of people across every continent on our planet. However, once the delicious fruit is harvested, the massive stem remains behind, often becoming a significant agricultural waste management challenge. For decades, these fibrous stems were simply left to rot in the fields, releasing methane and wasting immense potential industrial value. But hidden within these discarded layers lies a powerful natural fiber, waiting to be extracted by modern engineering and automation systems. Today, we explore the sophisticated supply chain that rescues these stems, turning an environmental burden into a profitable and eco-friendly product. The process begins with precise harvesting, where skilled teams cut the stems into manageable logs, ensuring consistency for the machines ahead. These stems contain a high percentage of water, requiring immediate processing to preserve the quality of the fibers locked deep inside. A coordinated fleet of transport vehicles carries tons of raw material daily, bridging the gap between the farm and the factory. We arrive at the processing facility, a hub of automation designed to handle organic matter with speed, efficiency, and minimal waste. Every load is meticulously weighed and cataloged, ensuring precise data tracking for production yields and payments to the local farmers. Automated cranes and mechanical arms take over, removing the heavy manual labor previously required to unload these water-heavy, bulky plant stems. The conveyor systems are built to withstand moisture and dirt, tirelessly feeding the hungry machines that await inside the main hall. The first step inside is purification, where high-pressure water jets blast away soil, insects, and debris from the outer bark layers. Cleanliness is crucial for high-quality fiber, as any remaining dirt could damage the delicate extraction machinery or contaminate the final product. Sustainability is key here, with advanced filtration systems recycling the wash water, drastically reducing the environmental footprint of this industrial process. Human oversight remains important, as skilled inspectors ensure only the healthiest stems proceed to the mechanical peeling and separation stages. The peeling machine mimics the human hand, but with superhuman strength and speed, stripping away layer after layer of fibrous sheaths. The outer sheaths contain the strongest fibers, so they are carefully separated from the softer, wetter inner core of the stem. Before extraction, the sheaths must be softened. Heavy rollers crush the plant matter, breaking down the cellular structure to release tension. This mechanical compression removes excess water and loosens the bonds between the fibers and the fleshy pulp that surrounds them. The transformation is visible instantly. What was once a rigid plant part is now a pliable sheet ready for fiber extraction. Enter the decorticator, the heart of the factory. This machine uses high-speed rotating drums equipped with blunt blades to scrape the material. The physics here is simple yet effective. The blades impact the leaf sheaths, knocking away the pulp without cutting the strong fibers. In slow motion, we see the violent yet controlled separation process. The unwanted organic matter is stripped away, leaving pure strands. Workers collect the emerging fiber bundles. At this stage, they are still wet and green, requiring further cleaning to reach perfection. Comparing the input and output reveals the machine's efficiency. Almost all non-fibrous material has been removed in a matter of seconds. Nothing is wasted. The pulp and juices scraped away are collected and diverted to a separate facility to produce organic fertilizer. The fibers now enter large soaking tanks. A biological enzyme solution helps to break down any remaining gum or sap residues. This enzymatic treatment is a critical step to ensure the fibers are soft, separate easily, and have a consistent, bright color. Robotic arms lift the heavy, wet bundles. Automation ensures consistent timing in the solution, preventing damage from over-soaking or under-cleaning. Industrial washers then rinse the fibers thoroughly. This removes the enzymes and loosened gum, leaving the fibers in their purest state. To speed up drying, high-speed centrifuges spin the fibers, using centrifugal force to extract the vast majority of the water content. In eco-friendly plants, fibers are often spread out on drying racks to bask in the sun, utilizing natural solar energy. Sun drying not only saves energy, but also naturally bleaches the fibers, giving them a distinctive, attractive ivory or golden hue. For consistent industrial output, thermal drying chambers are used. These ovens maintain precise humidity levels to prevent the fibers from becoming brittle. Engineers monitor the drying curves closely. If the fiber is too dry, it breaks. If too wet, it might mold later. Emerging from the dryers, the banana fiber is now a stable raw material, soft to the touch and ready for manufacturing. The carding machine combs the tangled mass. Thousands of fine wire teeth tease the fibers apart, aligning them in parallel strands. This process transforms the rough bundles into a smooth, continuous web, essential for spinning consistent yarn or creating high-quality paper pulp. Automation sorts the output. Long fibers head to the spinning department for textiles, while shorter fibers are diverted for paper production. In the spinning section, machines twist the aligned fibers into yarn. Banana fiber has high tensile strength, making for durable thread. The resulting yarn has a natural, rustic aesthetic. It is breathable, highly absorbent, and completely biodegradable, appealing to eco-conscious fashion markets. Industrial looms weave this yarn into fabric. The material rivals cotton and linen, offering a sustainable alternative for the textile industry. Beyond fabric, artisans craft these fibers into bags, hats, and mats, blending traditional craftsmanship with modern, sustainable material sourcing strategies. Meanwhile, the shorter fibers undergo pulping. They are mixed with water to create a slurry, the foundation of banana fiber paper. Screens lift the pulp from the water. As it drains, the fibers interlock to form strong, textured sheets of acid-free paper. Banana paper is prized for its texture and durability. It saves trees and provides a premium packaging solution for luxury brands. As the sun sets, the factory continues its work. This facility represents a shift in how we view agricultural byproducts globally. Data shows that producing banana fiber generates significantly less carbon dioxide compared to synthetic alternatives like polyester or water-intensive cotton. Farmers now have an additional income stream. What was once waste, costing money to remove, is now a sold commodity. The cycle closes, with the waste from extraction returning to the earth as rich organic fertilizer, nourishing the next crop. From the field to the factory, and finally to the consumer, every step adds value and reduces waste in this ecosystem. It is a perfect example of the circular economy. Nature provides the material, technology refines it, and we reap the benefits. Automation is the catalyst that makes this viable. Without these high-speed machines, processing such tough stems would be economically impossible. Precision engineering ensures these machines run for thousands of hours, handling the abrasive nature of plant fibers with minimal wear. Behind the scenes, software algorithms constantly optimize the flow of materials, predicting maintenance needs and maximizing daily fiber output yields. The demand for sustainable materials is growing globally. Factories like this are operating around the clock to meet the market needs. Containers loaded with banana fiber products leave the facility, destined for fashion houses, paper mills, and eco-stores around the world. Designers appreciate the material's unique properties. It blends well with other fibers and holds dyes vividly without harsh chemical treatments. Under a microscope, we see the secret to its comfort. The porous structure allows for excellent air circulation and moisture absorption. Back at the farm, the cycle renews. Banana plants grow rapidly, ensuring a constant, renewable supply of biomass for the future. Unlike trees, which take decades to mature, banana plants are ready for harvest in months, making them a superior renewable resource. Research continues to expand the horizon. Scientists are testing banana fiber composites for car interiors and durable, lightweight construction materials. Imagine driving a car where the dashboard is reinforced with banana fibers. This is not science fiction. It is developing reality. As we return to the factory floor, the final packaging stage is in full swing. Robots label and seal the products. These labels represent more than just a brand. They certify a commitment to a cleaner planet and a smarter industrial future. Day in and day out, the facility proves that economic growth and environmental stewardship can go hand in hand without conflict. Visionary leaders in the industry are investing heavily in these technologies, recognizing that waste is simply a resource in the wrong place. The human element remains vital. Automation supports the workers, creating safer, cleaner jobs compared to traditional manual agricultural processing methods. Education is also part of the mission. These factories serve as learning hubs, inspiring the next generation of green engineers. Witnessing raw stems turn into soft fiber sparks curiosity. It demonstrates the tangible power of science applied to real-world problems. Let's look closer at the maintenance tech. Automated lubrication systems inject precise amounts of grease, preventing friction and extending machine life. Smart sensors detect minute vibrations. This predictive maintenance ensures the line never stops unexpectedly, maximizing efficiency and profitability for the plant. When a deviation is detected, operators can adjust parameters remotely. This digital integration is the hallmark of Industry 4.0 factories. Energy efficiency is maximized by capturing waste heat from the machinery and redirecting it to the drying chambers, saving fuel. Rooftop solar panels supplement the power needs. The goal is a carbon-neutral operation that gives back more than it takes. The water treatment creates an ecosystem of its own. The final outflow is so clean that fish thrive in the monitoring ponds. This purity allows the water to be returned to the irrigation canals, completing the water cycle back to the banana fields. Inside the warehouse, electric forklifts glide silently. Every aspect of logistics is tuned to reduce pollution and improve worker safety. Automated storage systems stack the bales high. Computers track every bale's location, age, and destination, optimizing inventory management logistics. We are seeing the world through the eyes of the machine. It navigates with precision, never tiring, and never making mistakes. In the artisan wing, creativity flourishes. Dried flowers are pressed into the wet pulp, creating unique, high-value artistic paper sheets. These bespoke items command high prices in boutique markets, proving that industrial waste can be transformed into luxury art products. Consumers are increasingly choosing these sustainable options. Holding a banana paper notebook connects them to the story of eco-friendly innovation. Quality assurance is rigorous. Machines stretch the fibers to their breaking point to ensure they meet international textile strength standards. The results are impressive. Banana fiber rivals jute and hemp in strength, making it suitable for heavy-duty sacks and ropes. Its natural resistance to salt water makes it an excellent choice for marine ropes, a traditional use that is being revived. Automatic coilers wind the thick ropes. What was once a waterlogged stem is now a product capable of securing heavy loads. Let's revisit the extraction chamber. The internal liners are made of hardened steel to withstand the constant abrasion of the fibers. Modular design allows for quick maintenance. Worn parts can be swapped out in minutes, keeping downtime to an absolute minimum. Even the liquid sap is valuable. Rich in tannins, it is collected to be used as a natural dye for textiles. Fabric dyed with this sap takes on a permanent, earthy brown tone. It is a chemical-free dyeing process provided by nature. This natural dye is hypoallergenic, making the final clothing products ideal for people with sensitive skin or allergies to synthetic chemicals. The pulp waste also feeds animals. When fermented into silage, it becomes a nutritious feed for cattle in the local area. Farmers mix the pulp with other grains. This reduces their feed costs while ensuring the factory has zero waste sent to landfills. Alternatively, the pulp goes into biogas digesters. Bacteria break it down to produce methane, which can power the factory's generators. This clean energy can also be supplied to local homes, providing a sustainable cooking fuel alternative to wood or charcoal. Returning to the fiber line, Let's look at the enzyme treatment again. Specific bioagents target pectin, the glue holding fibers together. This biotechnology is precise. It dissolves the binding agents without degrading the cellulose, preserving the structural integrity of the individual fibers. Maintaining the correct pH balance is vital. Our chemists constantly monitor the solution to ensure the enzymes are active and effective. The result is a fiber that feels more like silk than wood. This quality is what makes banana textiles so desirable. For continuous drying, multi-tier conveyors are used. Hot air circulates through the layers, drying the fiber mats evenly from all sides. Moisture evaporates rapidly but gently. The controlled airflow prevents the fibers from tangling while removing water efficiently and thoroughly. Cooling fans bring the fiber temperature down instantly. This stabilizes the material before it is compressed into bales for shipping. Hydraulic balers compress the fluffy fiber into dense, manageable blocks. This reduces volume significantly, lowering shipping costs for international trade. Each bale is a compact unit of potential. From here, they can travel anywhere in the world to be transformed. Our tracking map shows exports reaching textile hubs in Europe and Asia. The global appetite for sustainable fibers is insatiable. In places like Italy, these fibers are blended with silk or wool. The result is a luxury fabric with unique characteristics. The blend offers the best of both worlds, the sheen of silk and the strength and breathability of the banana fiber. But the impact starts locally. The industry provides year-round employment for rural communities, reducing migration to overcrowded urban cities. Women in particular find skilled employment in these factories, operating machinery and managing quality control with expertise and dedication. Training programs upgrade the workforce's skills. Workers transition from manual field labor to becoming technical operators of modern machinery. Digital interfaces make complex machines accessible. A touch of a screen controls pressure, speed, and flow, empowering the operator. Environmental harmony is visible outside. The river remains clean, and the ecosystem thrives, proving that industry need not destroy nature. Noise pollution is also managed. Sound dampening walls ensure the factory hum does not disturb the local wildlife or residents. Maintenance is a daily ritual. At the end of shifts, machines are cleaned thoroughly to prevent sap buildup and corrosion. Compressed air removes dust from sensitive sensors. Keeping the equipment clean is as important as running it for longevity. Safety is paramount. Regular checks of emergency stops and guards ensure that the high-speed machinery poses no risk to humans. With the green light, the next shift begins. The cycle of production continues, driven by demand and powered by innovation. Let's look deeper into the papermaking. The beating process hydrates the fibers, causing them to fray and bond better. This creates a consistent slurry. The more the fibers are beaten, the stronger and denser the final sheet of paper. Natural dyes can be added directly to the pulp. Roots, leaves, and bark provide earthy tones without a single drop of toxic chemical. For industrial volumes, continuous paper machines roll out miles of paper. Steam-heated cylinders dry the sheet in seconds. Precision slitters cut the master rolls into user-specified widths. This paper will become packaging, labels, or artistic stationery. A major application is food packaging. Molded banana pulp containers are sturdy, oil-resistant, and replace polluting styrofoam and single-use plastics. After use, it returns to the earth. Within weeks, it decomposes completely, completing the cycle without leaving microplastics behind. The future lies in nanotechnology. Scientists are breaking fibers down to the nanoscale to create super-strong, lightweight materials. Nanocellulose, derived from bananas, is stronger than Kevlar and light as plastic. It could revolutionize aerospace and electronics industries. Imagine water filters made from banana waste that can trap bacteria and viruses. This is the potential of advanced biomaterials. Back in the factory, coarse fibers find their home in heavy textiles. Rugs and doormats utilize the fiber's natural toughness. Large looms weave thick, textured mats. These are durable enough for high-traffic areas and add a natural touch to interiors. Finishing involves trimming and smoothing. Workers ensure the pile is even and the edges are securely bound for durability. Rolled and wrapped, these mats are ready for homes globally. They bring a piece of the tropical plantation to urban living rooms. Interior designers love the versatility. Curtains, upholstery, and lampshades made from banana fiber offer unique textures and light diffusion. In a showroom setting, the material sings. It captures light beautifully and adds an organic, grounding element to modern decor. Advanced factories go a step further with reverse osmosis. This technology purifies wastewater to drinking standards for internal reuse. Every drop counts. Flow meters track the savings, proving that high-volume industrial processing doesn't have to drain local water resources. Rainwater harvesting supplements the supply. The factory roof acts as a catchment area, filling underground tanks during the monsoon season. This harvested water maintains the factory's green landscape. It is a self-sustaining loop that respects the local climate patterns. Technology improves quality control. Optical sensors scan the raw sheaths, automatically rejecting those with disease spots or rot. Air jets blast away defects instantly. This ensures that only premium raw material enters the extraction phase, guaranteeing top-tier fiber. Data collected here feeds back to the farmers. They learn which harvesting methods produce the best stems, improving future crops. Factory agronomists work in the fields. They teach farmers cutting techniques that preserve the maximum length and integrity of the fibers. Correct harvesting is crucial. Cutting closer to the ground yields longer fibers, which command a higher price in the market. Logistics also matter. Trucks are covered to prevent the stems from drying out in the sun before they reach the processing line. Sharp tools are essential. Automatic grinders constantly refinish the blades, ensuring a clean cut that doesn't bruise the delicate fibers. Microscopic views show the difference. A clean cut seals the fiber end, while a blunt impact leaves it frayed and weak. We have moved beyond traditional retting. Controlled biological tanks speed up the process from weeks to days without foul odors. The time savings are massive. What used to take weeks in stagnant water is now achieved in hours using specific bacterial cultures. These beneficial bacteria are hungry for pectin. They clean the fiber thoroughly, but stop before damaging the useful cellulose strands. Bioprocessed fibers are superior. They are finer, whiter, and softer, suitable for high-value textiles rather than just ropes. Combing machines refine the batch. They remove short fibers and tangles, leaving only the long, straight strands needed for spinning. Again, the waste from one process becomes the input for another. The combernoil, or short fibers, go straight to the paper pulp unit. The long fibers, now called sliver, are coiled into large cans. They are ready to be drawn out and twisted into yarn. Spinning frames draw out the sliver. Twist is added to bind the fibers together, creating a continuous, strong yarn thread. Often, banana fiber is blended with cotton. This combination improves softness while retaining the strength and luster of the banana fiber. The blend creates a unique texture. The slight irregularities give the fabric character, distinguishing it from synthetic, mass-produced textiles. Quality control never stops. Sensors check the yarn for consistency, ensuring there are no weak points that could break during weaving. Approved yarn is packed for shipment. Weavers around the world rely on these specifications to set up their looms correctly. Not all goes to industrial machines. Handloom weavers also prize this yarn, keeping traditional weaving heritage alive with new materials. The rhythmic clack of the handloom produces exquisite fabrics. Each meter is a testament to human skill, supported by sustainable agriculture. The finest fibers from the innermost sheaths are known as banana silk. They create scarves so light they float on air. Fashion meets function. These accessories are not just eco-statements. They are genuine luxury items that compete with high-end silk. Another innovative product is the biodegradable plant pot. Molded from the pulp, these pots can be planted directly into the ground. Gardeners love them. There is no plastic waste, and the decomposing pot actually provides nutrients to the growing plant roots. Even egg trays get an upgrade. Banana pulp is stronger and more water-resistant than standard recycled paper pulp used for packaging. Structural integrity is tested by stacking. These trays protect fragile goods during transport while remaining 100% compostable after use. Supermarkets are adopting this packaging. It signals to customers that the retailer is serious about reducing their plastic footprint. Consumer awareness is driving change. People are willing to pay a premium for packaging that doesn't harm the planet. Overseeing it all is the central control room. Here, data from every sensor converges to provide a real-time health check of the plant. Data analytics drive continuous improvement. We can identify bottlenecks and energy spikes instantly, refining the process day by day. The digital backbone is as important as the steel machinery. It ensures traceability, allowing us to track a fiber back to its farm. Traceability builds trust. A simple QR code scan tells the consumer exactly where their product came from and how it was made. As the day ends on the plantation, we reflect on the journey. It starts with the soil and the people who tend it. The banana plant gives generously, fruit for food, leaves for cooking, and now stems for the industries of tomorrow. We have seen the transformation. A simple agricultural byproduct has been elevated into a versatile industrial material through automation. Automation is the key enabler. It provides the scale, consistency, and cost-effectiveness needed to compete with synthetic alternatives. This model is replicating globally. From Asia to Latin America, banana-producing nations are waking up to this golden opportunity. It is a blueprint for the future of manufacturing, one that works with nature, not against it, creating wealth from waste. The future holds even more. We are experimenting with fiber-reinforced concrete blocks that are lighter and more insulating than standard bricks. These green building materials could revolutionize construction. They sequester carbon and provide excellent thermal insulation for energy-efficient homes. Interior design is also evolving. 3D wall panels made from pressed pulp offer acoustic benefits and stunning visual textures. Hygiene products are another frontier. The fiber's high absorbency makes it perfect for biodegradable diapers and sanitary pads. The environmental impact is profound. Replacing plastic-based hygiene products with compostable ones solves a massive global waste problem. Investment is flowing in. The financial world recognizes that sustainable technologies are not just ethical, they are profitable. We are expanding. New lines are being installed to keep up with the demand, bringing more automation and efficiency. The next generation of robots is arriving. Autonomous mobile units will replace static conveyors, creating a flexible, fluid factory floor. Cobots work side by side with humans. They handle the repetitive strain tasks, allowing workers to focus on supervision and quality. Artificial intelligence is getting smarter. Visual inspection systems learn to spot defects that the human eye might miss. Machine learning algorithms constantly tweak the process parameters. They squeeze every ounce of efficiency out of the energy and raw materials. We are moving towards dark factory concepts for certain sections. Robots don't need light, saving even more energy during night shifts. But human creativity remains irreplaceable. Machines can execute, but people dream up the new products and applications for this material. Designers are pushing boundaries. From shoes to furniture, they are finding ways to integrate banana fiber into our daily lives. Sneakers are a great example. Durable, breathable, and eco-friendly, they appeal to the massive, sustainable fashion market. The fabric withstands wear and tear. It keeps feet cool and dry, proving that eco-fashion doesn't mean compromising on performance. End of life is also considered. These products can be shredded and repulped or simply composted, leaving zero trace. This is the ultimate goal, a truly circular economy. We borrow from the earth, use with respect, and return without harm. We are planting seeds for the future. Teaching the next generation about these resources ensures the sustainability movement continues to grow. The potential is as vast as these fields. Millions of tons of stems are available worldwide, ready to be utilized. Nations across the tropics are joining in. From Asia to Africa, the banana fiber revolution is going global. Knowledge sharing accelerates progress. International experts collaborate to refine the machinery and share best practices for fiber extraction. Global trade is shifting green. Shipping containers are increasingly filled with sustainable alternatives to plastic and synthetic materials. It is truly green gold. A resource that was once ignored is now a pillar of the new bioeconomy. At Factory Automation Future, we are proud to document this shift. We believe technology is the bridge to a sustainable world. It is a story about people as much as machines. It's about dignity, employment, and pride in creating something good. From coarse ropes to fine paper, from rugged mats to silky scarves, the versatility of the banana stem is astonishing. The choice is clear. We can continue filling the world with persistent waste, or we can choose materials that leave no trace. Every purchase is a vote. By choosing sustainable fiber products, consumers drive the demand that makes these factories possible. As the sun sets on our journey, we hope you are inspired by the potential of industrial ingenuity. Nature provides the solutions. It is up to us to build the machines and systems to unlock them responsibly. From the harvest to the extraction, from the drying to the weaving, it is a symphony of biology and engineering. Innovation for a greener planet is not just a slogan, it is the operational reality of the facility we toured today. We thank the engineers, farmers, and workers who opened their doors to show us the future of fiber production. This factory is just one dot on the map, but it represents a giant leap in our journey towards sustainability. The machines may rest or run through the night, but the impact of their work lasts for generations to come. Like the young shoot rising in the mist, hope for a cleaner industry is growing stronger every single day. Let us cherish these resources. Let us support the technologies that protect the purity of our natural world. The next time you see a natural fiber product, remember the incredible journey it took to reach your hands. Wear it with pride. You are carrying a piece of the solution, a product of nature refined by human intelligence. We have reached the end of this journey. But for the banana fiber industry, this is only the beginning. If you enjoyed this deep dive into industrial recycling, check out our other videos on automation and green technology.